Okay, guys. In number 29, 30, and 31, we're going to go over the expected value of an event. Now, the expected value or the expectation is the result of what we expect to happen after performing an experiment numerous amount of times. And the events must be numerical events. The expected value is also considered the average of what somebody is expected to win or expected to lose. To find the expected value, we use the expected value formula, which is stated as E, well, E of X sometimes, is equal to the sum of your events times the probability of those events. We can also write it as E is equal to event 1 times the probability of event 1 plus numerical event 2 times the probability of numerical event 2, so on and so forth for how many events we have. All right. To find the expected value for this random variable, which is this table, our expected value will equal to E is event 1, x1 is 2. And we're timesing the 2 by the probability of having a 2, which is 0.4. Plus, the second numerical event is 3. And the probability of receiving a 3 in this case is 0.2. Plus event 3, which is a 4. And the probability of receiving that 4 is 0.1. Plus the fourth event, which is receiving the number 5, times the probability of receiving that 5, which is 0.3. And now we can multiply. This is going to be 0.8 plus 0.6 plus 0.4 plus 1.5. And now let's add that all together to get 3.3. And this is the expected value. And the expected value can be between any negative and positive number. Probability must be between 0 and 1. The expected value can be between any negative and positive number. All right, let's do number 30. In a game, you have a 1 in 20 probability of winning $76 and a 19 out of 20 probability of losing $9. What is the expected value? So I'm going to call this right here of winning $76 as my event 1. And event 2 is going to be losing the $9. Let's put that in blue. The probability of event 1, we have a 1 in 20 chance of winning the $76. That's the probability of event 1. And the probability of me losing $9 is the probability of event 2. So now we can find our expected value. Event 1 is $76 times the probability of me winning $76, that's 1 out of 20. Plus event 2, I am losing $9. So because I'm losing, I must make that negative. And the probability of me losing $9 is 19 out of 20. So here we have, make this into a fraction. That's going to be 76 over 20. A positive and a negative makes a negative. Put this number over 1. 9 times 19, that is 171. And 1 times 20 is 20. And you guys can use your calculator for this. You should use your calculator. Don't be like me doing this in my head. But when I subtract the tops, this is going to equal to negative 95 over 20. And that means my expected value, you're going to lose $4.75. You are expected to lose $4.75 based on this experiment, this game. All right. So easy expected value, medium expected value. Let's do a hard expected value question. And as you know, I don't do my questions in order when I make the videos. It says for number 31, a lottery offers one $1,000 prize, one $500 prize, and 8 $100 prizes. 1,000 tickets are sold at $4 each. Find the expectation if a person buys 5 tickets. Okay. In this question, let's first find the expectation that a person buys 1 ticket. When we find that expectation, we can multiply that by 5. All right, so we have different kind of prizes. So let's have prizes up here. Let's have X for our dollar amount. And let's have P of X for our probability of receiving that amount. Okay, so we have prize number 1, which is the $1,000. Prize number 2, receiving 500. Prize number 3, 8 people can receive $100. But you can't forget, if there are winners, there are also losers. So we must look at also somebody who didn't receive nothing, no prizes, none. Now, remember this. It says that 1,000 tickets are sold at $4 each. You're paying $4 per ticket. Put yourself in the scenario. Let's say you spent $4, right? And your ticket was the ticket that gave you the $1,000 prize. So that means you got your $4 back. And you got back in addition $996. You spent 4, you got 1,000. Your profit was $996. So you're not gonna put 1,000 here. Do not put $1,000 here. Do not do that. No, put an X through that. Do not do that. Your expected value is based on your profit. And your profit in this case is going to be $996. You spent 4, you got 1,000, you really got $996 because you still lost 4 in the beginning. And there's only one ticket that gives you the prize of $1,000. That is one ticket out of 1,000 tickets. For the second prize, there is only one $500 prize. So only one out of 1,000 tickets can give you the $500 prize. Let's say that you have that ticket. So that means you have earned the $500 prize. But remember, you still spent $4 on that ticket. So that means you didn't necessarily win $500. You won $496. Because you're getting back the $4 you had before you won. The third prize, there are 8 $100 prizes. So that means 8 of the $1,000 tickets that were sold contains the $100 prize. Let's say if you're one of the people that receives a $100 prize, you still spent $4 to buy the ticket. So you're not really getting $100. You are winning $96. And last but not least, if you are not a winner, unfortunately, that means you are a loser. And if you don't get none of these prizes, that means you lost $4. And if you count, there are only 10 prize tickets. 1 for prize 1, 1 for prize 2, 8 for prize number 3. So if only 10 of those tickets give you a winning amount, that means the other 990 tickets sold are losing amounts out of 1,000. Now that we set up what is called a probability distribution, we can find our expected value. Put some more space over here. So our expected value, E, that is going to equal to the first place prize, 996, times 1 over 1,000, plus 496 times 1 over 1,000, plus $96 times 8 over 1,000. And now look here, this is negative. So it's going to be minus $4. And that's going to be 990 over 1,000. All right. You can multiply all this in your calculator and then add them together. We're now going to go up here. So E is equal to, when you multiply the first one, that is going to equal to 96 cents. Well, 0.996. 99 cents. 99, really, yep, 99.6 cents. Plus, when you do the second one, that's going to be 0.496. When you multiply 96 with 8 over 1,000, that's plus 0.768. And then when you look at the 4 times 990 over 1,000, that's going to be minus $3.96. So my expected value, when I complete all this and I add and then subtract 0.996 plus 0.496 plus 0.768 minus 3.96, 1.7, negative 1.7. So this equals to negative $1.70. But this is not your answer. This is how much you're expected to lose if you buy one ticket. For one ticket. For 5 tickets, your expected value, E, you're going to multiply this negative 170 by 5. So 5 times negative $1.70, which means you lost $1.70. This equals to the overall amount of you losing $8.50. You are expected to lose $8.50 if you purchase 5 tickets by playing this game. All right, guys, that's it for this video. Hopefully that made sense. Hopefully you liked it, and I'll catch you in the next one. Take care.